Welcome to physics class. Today we are going to tackle about distance and displacement, speed and velocity, as well as the acceleration. This is Miss Chen and we are going to discuss first about speed. Speed is a fundamental concept in physics that describes how quickly an object is moving. It is a scalar quantity, meaning it only has magnitude and no direction. Speed can be calculated by dividing the distance traveled by the time it took to cover that distance. For example, if a car travels 100 kilometers in 2 hours, its speed would be 50 kilometers per hour. Speed is crucial in various real-world scenarios such as determining travel times, analyzing the performance of athletes, or evaluating the efficiency of vehicles. In everyday life, we often encounter speed measurements when driving cars, riding bicycles, or running on a track. For instance, consider a cyclist pedaling along a straight road. If the cyclist covers the distance of 20 kilometers in 1 hour, the speed of the cyclist would be 20 kilometers per hour. This measurement indicates how fast the cyclist is moving along the road without considering the direction. Let us now proceed to velocity. Velocity extends the concept of speed by including both the speed and the direction of the motion. It is a vector quantity, meaning it has both magnitude and direction. While speed tells us how fast something is moving, velocity provides information about both the speed and the direction in which the object is moving. Velocity can be calculated by dividing the displacement by the time it took to undergo that displacement. For example, if a car is traveling at 60 km per hour north, its velocity would be 60 km per hour north. Velocity is crucial in navigation, robotics, and other fields where directionality matters. Consider a boat sailing across a lake. If the boat travels a distance of 10 kilometers directly east in 1 hour, its velocity would be 10 kilometers per hour eastwards. The measurement not only indicates how fast the boat is moving, but also the direction in which it is heading. Let us now proceed to acceleration. Acceleration is the rate of change of velocity concerning time. It is a vector quantity, meaning it has both magnitude and direction. Acceleration occurs when an object changes its speed, direction, or both. When an object accelerates, its velocity changes over time. Acceleration can be calculated by dividing the change in velocity by the time it took for the change to occur. For example, if a car increases its velocity from 20 meters per second to 30 meters per second in 5 seconds, its acceleration can be calculated as 30 meters per second to 20 meters per second multiplied by 5 seconds is equal to 2 meters per second. Acceleration is a fundamental concept in physics and plays a crucial role in describing the motion of objects in various scenarios. One example of acceleration is a car speeding up or slowing down on a highway. When a car accelerates, it increases its velocity over time, while deceleration occurs when it decreases its velocity over time. For instance, if a car goes from 0 to 60 miles per hour in 10 seconds, it is accelerating. Conversely, if the same car slows down from 60 mph to 0 miles in 5 seconds, it is decelerating. Acceleration is also observed in everyday scenarios such as when a ball is thrown into the air. As it accelerates upwards due to the force of gravity acting upon it. Another example of acceleration is when a roller coaster moves along its track. As the roller coaster descends a steep hill, it accelerates due to gravity, increasing its velocity. Similarly, as it ascends the hill, it decelerates, decreasing its velocity. This variation in velocity over time demonstrates the dynamic nature of acceleration and its role in describing the motion of objects. Acceleration is essential in understanding how forces affect the motion of objects. and is a key concept in physics and engineering.
In the next video, we are going to discuss about distance and displacement. In the realm of physics, distance and displacement are fundamental concepts used to describe the position change of an object relative to a reference point or frame of reference. While both terms seem similar, they convey distinct meanings and have different implications in understanding motion and spatial relationships. What is distance? Distance refers to the total length of the path traveled by an object, irrespective of direction. It is a scalar quantity, meaning it possesses only magnitude and no directional information. In simpler terms, distance measures how much ground an object covers during its motion. The standard unit of distance in the International System of Units (SI) is the meter m. Displacement, on the other hand, signifies the change in position of an object from its initial point to its final point, along with the direction from the initial to the final position. It is a vector quantity, characterized by both magnitude and direction. Unlike distance, displacement considers the shortest path between the point and ignores the intermediate path taken by the object. Example: consider a car moving along a straight road. Suppose it starts at point A and moves 3 kilometers to the east, reaching point B. Answer: the distance the car traveled is 3 kilometers, as it covers the entire length of the road from point A to point B. Displacement: the displacement of the car is 3 kilometers to the east. It represents the straight line change in position from the initial point A to the final point B. Considering both magnitude 3 kilometers and direction east. Another example: imagine you walk from your house to the grocery store, which is 500 meters to the east. Distance: the distance you walk is 500 meters. Displacement is 500 meters to the east, because you moved in a straight line from your house to the grocery store.
That will be all, and thank you for listening.